All right, I wanted to do a quick review of polar coordinates with you. This is not going to be in depth. You guys talked about this in Calc 2, but I just wanted to give you the overview of the basic framework. So I have a point xy in the standard Cartesian system, and I can think about if the angle formed by the line segment from the origin to my point, the angle between that line segment and the positive x-axis, call that angle theta, and then think about the distance between the origin and my point, call that distance r, and that's actually all that polar coordinates is. You just encode, you say r comma theta, and so xy in Cartesian coordinates is the same as r comma theta in polar coordinates. A couple of key conversions that you should know: x is r cosine theta, y is r sine theta. By the way, you can see that instantly off of the triangle here. I'm going to let you check it, but you're going to think about this side is just length x, and this side is just length y, and so these formulas all become apparent. X is r cosine theta, y is r sine theta, and x squared plus y squared off the triangle you can see has to be r squared, or you can also use these formulas and plug them in, and either way you get x squared plus y squared is r squared. Let's erase this stuff now. One other useful formula is what happens if you take y over x. Well, you get r sine theta over r cosine theta, which the r's cancel. This is just tangent theta. And so sometimes it's helpful to realize that theta is actually the inverse tangent of y over x. So there's a lot more that can be said, but those are the key conversions if you want to write something down in terms of polar. A couple of other little examples, I suppose. If I write down like r equals 2, this is a circle of radius 2 centered at the origin. Why is that? Well, theta can swing all the way around, but r is always 2, so you're literally living on that circle, and so on and so forth. So I'll do some more polar in the video with you, but these are more or less what you're going to need. I should mention graphing polar. Sometimes you'll have r equals a function of theta, and so the idea is you graph this in the R Theta plane, and then you use that graph to come up with, to find the actual polar graph. So maybe I should do just a quick example of this. Let's look at an example that we'll actually see in the notes. So I'm going to write down with you, I'm going to write down the equation r equals 1 minus cosine of theta. I'd like to find the polar graph of this. So first I'm going to graph this in the R Theta plane. And how do I do that? Well, this is going to be my theta, and this is going to be my r. And so let's think about it together. When I plug in, here I think I'm just going to plug in multiples of pi halves. So when theta is 0, r is 0. You can see that. When you plug in theta equals 0, r is 0. When theta is pi halves, cosine of pi halves is 0, so r is 1. When theta is pi, r is actually 2 now, because cosine of pi is negative 1, so I'm there. When theta is 3 pi halves, r is back to 1 again. And then, of course, when theta is 2 pi, I should be labeling these pi halves, pi, 3 pi halves, 2 pi, then r is back to 0. So I get this shape. Whoa, that wasn't very good. I get this shape for my graph in the R Theta plane. Now I can use that to actually come up with the true polar graph. How do you do that? Well, you do it like this. So now I'm going to give the actual polar graph, and I'm going to say, okay, first off, when theta is 0, r is 0. I'm sitting right here. As theta swings around, as theta swings from 0 up to pi halves, what is r doing? R is going from 0 up to 1. So that's going to swing out, R is going to swing from 0 up to 1, and I'm going to trace out something that looks like that, because as theta is swinging, R is lengthening from 0 up to length 1. And now, as theta swings around from pi halves to pi, so here I am at pi halves, theta swinging me down to pi. What's R doing? R is going from 1 to 2, so it's actually going to swing down. Maybe here's 1, here's 2. R is going to stretch out like that. All right. Now, as theta swings from pi down here to 3 pi halves, R is going from 2 back to 1. So I'm going to arc something like this. And then as theta swings from 3 pi halves back up to pi halves, I'm going to go from 1 to 0. And so I actually trace out a cardioid. So this is actually the true polar graph, but you can use this graph over here in the R theta plane to get that. So hopefully that helps. Make sure that you know these 4 equations. Those are absolutely imperative. And then we'll practice this some more as we dive into